cloud data engineer in Google Cloud's professional services.
Hello everyone, I'm Pratap. I'm also a cloud data engineer in Google Cloud Professional Services working out of Bay Area.
And today we're going to be talking about Flex templates, which allows you to easily turn any Dataflow pipeline into a reusable template that anyone can run. So over the next 15 minutes, we'll start by talking about a Dataflow job without templates. And then we'll talk about the separation of roles between developers and users who want to run the templates. And then I'll talk about traditional templates and then hand it off to Pratap to talk about Flex templates and some production ready Google provided templates as well. So let's talk about the life of a Dataflow job. The left side here shows the pipeline construction phase. So the developer is creating a environment and building a pipeline and then packaging and sharing that into GCS as a pipeline jar for Java. So before templates, it was challenging for developers to share these pipelines with coworkers. Um, the development environment for the developer would, for Java, involve installing a JDK, the Apache Beam SDK, and Maven or Gradle typically. For Python, it would be a Python installation and pip. And then the developer would write the pipeline code, build the binary artifact, which would typically be a fat jar with dependencies or its Python equivalent, and then share that artifact through Google Cloud Storage, GCS, or the Artifactory. And next, the user wants to run that pipeline. So they would need to first set up a local runtime environment, which was non-trivial. For Java, that would require installing Java JRE. For Python-based pipelines, the runtime user would need to install Python and all of the packages that the developer used during development. Even scheduled pipelines, as you can see in yellow up here, even scheduled pipelines would need a similar runtime environment to exist, complicating the automation process. So whether the user is running the pipeline manually or it's being scheduled to run automatically, once the pipeline is run, an execution graph would get generated in the runtime environment, and then that graph is sent to the Dataflow service to run as a Dataflow job in the cloud. Before running the Dataflow job, the Dataflow service will validate the permissions and quota checks to ensure that the job is going to be successful. So as you can see, there are several points here where something could break. And like I said, setting up this runtime environment made running Dataflow jobs tricky for users. So what we want to talk about is some of these challenges. The development team wanted to essentially build and share reusable pipelines easily. And business users want to launch these pipelines without the need to set up environmental dependencies. And users also want to be able to schedule jobs using cloud native services like Cloud Scheduler without having to, again, set up runtime environments for the scheduler. So our solution to these problems was to separate the pipeline authoring, the development stage, from the pipeline execution stage as two independent roles. And we originally came up with the idea of traditional templates to do this. So the templates will separate the pipeline construction and execution stages. In the construction phase, a developer will still set up a development environment like before, create the Beam pipeline and write codes and tests. And then the developer will stage the serialized DAG, the directed acyclical graph, or the execution graph, as a template on cloud storage. In the execution phase, the users will execute the pipeline by referring to the template. And In addition to that, you can also execute templates via a variety of channels like the GCP console, the gcloud command, REST API, or cloud native schedulers like Cloud Scheduler in Google Cloud. And regardless of how a user is running it manually or it's being automated, there is no runtime dependencies. So here's the same diagram as before, but let's look at it through the experience of traditional templates. So first, when the developer runs the pipeline code on the left in the development environment, you can see now the pipeline gets converted into a Dataflow template that's stored in GCS. This is the staged template that consists of a translated JSON execution graph along with dependencies like pipeline artifacts and third-party libraries. That execution graph is permanently fixed, and the user cannot change the shape of the DAG during runtime. And once the GCS bucket permissions have been adjusted to share with users, they can invoke the pipeline by passing in any required parameters directly. Just notice that whether this is a scheduled pipeline or a manually run pipeline, there's no need for a runtime environment. So how do you create a template? So to create a template from your existing Apache Beam pipeline, you must modify the pipeline code to support runtime parameters by implementing the value provider interface. Dataflow templates use runtime parameters to accept values that are only available during pipeline execution when you're running the pipeline. And implementing the value provider allows a developer to defer the reading of variables to whenever the template is actually run. For example, a developer may know that the pipeline will read from PubSub, but wants to defer the name of the subscription for the user to pick at runtime. All right, so the value provider interface gets updated, and then the second step is to include an extra parameter called -- template location when running the pipeline. So you can see that is in the Java command below, and the template location is on GCS here. So once you update that template location, now when you run the template as a developer, it will actually make that staged JSON execution graph in GCS, which is what we call the template. For more detailed instructions, check out the links below for creating traditional templates and launching templates. But even with traditional templates, there are some limitations. First, the I/O connectors need to support this value provider interface to accept those runtime parameters from the user. Keep in mind that the I/O connectors for Apache Beam can run on various runners like Dataflow, Spark, or Flink, and only some of the I/O connectors contained methods that accept the value provider objects. The IOs with supported methods have an overload with a value provider. Some of these include like BigQuery IO, PubSub IO, Spanner IO, File IO, but not all of the third-party database storage and messaging products were implemented with value provider. If a method does not have the overload, the method does not support runtime parameters, and not all external systems supported it. So because traditional templates dependency on value provider's interface, developers had to select the pipeline source and sink from a limited set of options. If the third-party connector didn't support it, then you couldn't use that in a traditional template. And second, there was a lack of support for dynamic graph execution. So since the Dataflow pipeline execution graph is permanently fixed when the developer converts the pipeline into a shareable template, the template could then only be run to accomplish that specific task that the developer originally had in mind. So for example, choosing a sink to write to, such as cloud storage or BigQuery, had to be predetermined at the template creation stage and could not be dynamically decided based on the user's choice during template execution. This meant that developers sometimes had to create templates with minor variations, such as whether the source was cloud storage or BigQuery. So now I'd like to hand off to Pratap to talk about how Flex templates remove both of these limitations.
Hi, can you hear me? Yep. Thank you, Sumit. Flex templates is relatively new concept, which is currently in beta and expected to go GA very shortly. So in Flex templates, we still retain the core concept of the original traditional templates where the construction and execution are seen as two independent phases. But however, the Flex templates has taken a different approach in terms of the way the pipeline artifacts are packaged. If you have noticed earlier in traditional templates, once the developer finishes writing the code, and if the developer runs with adding that extra parameter that Samir was talking about, the entire pipeline request gets serialized as a JSON and is staged on the Google Cloud Storage as a template. But in case of Flex templates, we build a Docker image containing these pipeline artifacts, and on top of that, we'll create a template spec file. I'll go in detail like how to do this and what these each of these contains. Now, in the execution phase, the user executes the pipeline just referring to this template spec file, which is stored on the Google Cloud Storage. So all the traditional channels that users had with respect to traditional templates is available even in the Flex template. So they can use console, gcloud, REST API, all these channels in order to execute the template. If you notice this, at the right-hand side of pipeline execution and data flow runner, those two parts remains the same as we have seen in the traditional templates. The only major difference is in terms of how the pipeline is packaged. In case of traditional templates, it was packaged as a serialized JSON file on the Google Cloud Storage, whereas in this case, we are packaging the pipeline artifacts as a Docker image, and also we are creating a template spec file, which basically refers this image and they has a template metadata like what is the template name, description, and what are the parameters that are required for the user to launch this template. So only the left hand side of the pipeline construction phase is what is different from the traditional templates. How do we create these Flex templates? Well, there are two steps. The first step is you need to create a Docker image. Dataflow team provides a set of base images for different languages. For example, in the one that you're seeing is provided for the Java 11. On top of that, you'll keep adding your pipeline artifacts and any environment variables. And the brownie point here is you don't need to really have a Docker environment to be installed on your system. You can take advantage of gcloud builds command to build a Docker image from this Docker file. So once the Docker image is built, the gcloud build command also pushes automatically the Docker image to the Google Container Registry. The next step is to write a template spec file. We also have a gcloud command that allows you to make this very easy. All that you need to do is create your metadata file, which, as I said, which has the name of the template, description, and the parameter information. It can also have certain regexes so that you can make the users to stick to a specific format when they're supplying the runtime parameters. And finally, this file gets stored on the GCS. So for detailed instructions, you can check out the link that was provided below. One major difference between the traditional templates and the Flex templates is the phase in which the execution graph gets built. If you notice earlier, in case of traditional templates, the execution graph gets built whenever the developer stages the template. Whereas in the case of Flex templates, that is deferred until the user runtime. So this graph gets built whenever the user launches the template. So this has allowed us to go ahead and fix some of the limitations that Samir was talking about with respect to traditional templates. But what exactly is the dynamic job graph execution, right? Imagine in your pipeline, you have a certain conditional statements and you want to build the nodes based on how the user supplies the parameters. Say you have a streaming pipeline that is collecting events or a certain window, and you would like to stage those events either in Google Cloud Storage or in BigQuery, depending on the user's choice. Now, you can't do that in the case of traditional templates because that has to be determined while the template construction phase itself. But now in case of Flex templates, you can allow the users to supply the choice of sync. Hey, do I need to store in GCS or do I need to store in BigQuery? Now, based on the user's choice, automatically the graph gets constructed to choose the appropriate sync. So in that way, now there is no need to build two variations of the template for the same pipeline. The second advantage is There is no need of any more value provider interface requirement, which ultimately opens up the choice to use any pipeline irrespective of what IO are you using that can be converted into a template. So these two limitations has been fixed in the Flex templates. Over time, we have seen that several customers has a large need for migrating the data from one system to another system within their organization, but they are constrained either due to resource requirements or budget constraints. So we decided to go ahead and help them by building a large collection of predefined data flow pipelines and stage them as templates on Google Cloud Storage. As I said, these are primarily used for point to point data transfers, but we do support some simple transformations through a JavaScript UDF. So users can build a JavaScript UDF and supply the location of the JavaScript file to the template, and this UDF gets executed for each record in the pipeline. These transformations are record level transformations like either filtering or mapping. So some simple transformations are possible. These are extensively used by several enterprises. The great benefit of this is you don't even need to write a single line of code, and it is readily available for you to use on the Google Cloud. We also open source this templates, and you can check out the code as well. And the extensive documentation is available on Google Cloud. Since this is open source, there is a large active community support. We welcome all your contributions. By now, I'm curious that you might be thinking, hey, how can I use these templates? Well, all that you need to do is get into the GCP console. Under the data flow section, you'll find a button called Create Job Front Template. So once you click on that, you will land into the screen that I'm showing you. You can give the job name. You can choose the template that you're interested in. Once you choose the template, on the right side, you can see the graph showing you what are the different nodes in this particular graph. And also the extreme right, you can also see a screen where we explain what this pipeline is all about and what are the requirements for this, like what parameters are required and what is the specific format that you need to enter those parameters. Once you supply them and click run, then this pipeline automatically gets launched for you. Console is not the only way you can launch. You can also use gcloud command, you can use REST API, and all these instructions are available in the Google Cloud documentation. Here is a long list of portfolio that is available for you. Due to space constraints, we cannot provide everything, but there's a long list that you can find it out on the Google Cloud console. If you observe, there's three categories: stream, batch, and utilities. You can find all these things in the documentation as well. Recently, we released a streaming data generator template, which is primarily used for publishing large volume of messages. You can also define your own schema. I've written a blog that explains all the details on how to use this template and what are the various use cases that this can be used for. So please check out the blog as well. Well, that brings us to the end of the presentation. Time for questions.
Thank you, guys. At the moment, I haven't seen any questions. We'll give it a moment, a minute or two, I guess.
Cool. Yeah, I do want to thank the names at the bottom of the slide for the design and development of the Dataflow Flex templates. And like Pratap said, we are planning on publishing a detailed blog talking about Flex templates and its architecture on the Google Cloud blog next week. So check that out for more details.
We do have one question that I'm reading here. Are Google Cloud provided templates Flex templates technically or traditional?
We have a combination of them. We have both traditional templates as well as Flex templates.
All right. And
Yeah,
I guess
code for both are available on GitHub, so you can check them out and see how we develop them.
and the next is votes in Dataflow template. You specified the SDK as Java. How would one work with the portability framework that would require both Python and Java?
Flex template supports both Java as well as Python.
Yeah, and I think you have to kind of pick between the two and make your template in one of them. So I'm not sure if you can really use a combination of the two. Have you seen that, Pratab?
No, I don't think so. Cross-language transformations is yet supported in the Flex templates.
Yeah, that's what I thought.
Well, so that seems, if not, whoever suggested that question, that's a feature request.
Uh-huh.
Anyways, cool. That looks like it's it for questions. Perhaps everybody feel free to throw more questions in the Slack room if needed, or there's probably other ways to get a hold of and contact these guys. Thank you very much.